It's time for another math easy solution. Trying to discuss further into trigonometric integrals, and now go over example 8 of the example series, and I'll go over a pretty interesting integral. This one here is the integral of secant cubed of x dx. Now this one doesn't fit into our guidelines, which I went over in my earlier videos, so we would have to do basically something slightly different to solve this integral. Now it's not that straightforward to solving this integral, but we'll take this note from our calculus book, which states that if an even power of tangent appears with an odd power of secant, in this case we'll consider power of tangent as 0. It's close enough to being even. It is helpful to express integrand, or this function, completely in terms of secant, and it may require integration by parts. So this is just giving us a hint on how to solve this. And when we look at this function right here, we could write this as basically secant of x, secant squared of x dx. And the reason we do this is because when you ever have a secant squared, you can convert this to a tan squared of x, or you could also use the integral of this. We know the integral of secant squared, so when we look at this integral of secant squared of x dx, we know this equals to tan of x plus c. So since we know this, and this becomes, well, simpler, I'll write that, so it becomes simpler, we could try integration by parts. So if we write down, well, we know the formula, I'll write by parts right here. So by parts, we know the formula is u dv equals to uv minus v du. So when we look at this right here, since we're taking an integral right here, we can consider dv, so we let dv equals to secant squared of x dx right here. So the integral of this is going to be v, that equals to, well, tan of x. So that's the integral of that. So we'll be left with u equals to just regular secant of x. And then the differential or derivative here is going to be secant x tan of x dx right here. So now we could throw this inside our integration by parts. So we get integral of secant, which is u of x, dx right here, equals to, actually no, not dx, I mean now we have secant squared of x dx, that's our dv, and that's just basically our dv right here. Yeah, that's right here, so that's our dv, and this is our u. Yeah, now this equals to u, which is secant of x, times it by v, which is tan of x, minus now the integral of v, which is tan of x. And now we have our du, which is secant x tan of x dx. So we'll just square this and put a secant x dx right here. So now that we have this, we could simplify this, write this all in terms of secant. And that comes again from our note right here. If an even power of tangent appears with an odd power of secant, so there's an even and odd, we would write everything in terms of secant right here. So when we write everything in terms of secant, we use the trig identity, secant x tan of x minus, so tan squared, this equals to secant squared of x minus 1. So that's a trig identity, you should memorize that. I also have a proof of that in the video link below. So now we have secant x dx. So now we can multiply this inside, and then so secant x tan x minus, multiply this inside, and we'll separate it. So we'll separate it because, yeah, it becomes simpler, and I'll show you why. So we get a cubed of x dx plus, so there's a minus become positive. Now integral of secant x dx. So now this is what we started off with. This is the exact same thing. So we can move this over to the left side. So we get basically, so we move it over. So we add it. So we get 2 times integral of secant cubed of x dx, the cube, the same thing as this, equals 2 secant x tan of x. And now this part right here, we know this, yeah, you can also see the proof for this one. The integral of this is equal to ln of absolute value of secant x plus tan of x right here, and we have a constant, but we'll just divide everything by 2 right here. So we just divide this out by 2, so we get 1/2. And now we just add a constant. I didn't divide the constant by 2 because a constant divided by 2 is still a constant. So we just move that over here, and this is our final answer right here. That's the integral right there. Anyways, that's all for today. If you learned from this pretty clever way of solving this integral. And actually, just one more note, integrals such as this one may seem special and just pretty like ridiculous in solving this, but in my later videos I'll show that they do in fact occur frequently in real life applications of, well, integral calculus and trigonometric integrals for some stuff like volumes or surface areas and just a lot of stuff, probably electric parts, something like that. Anyways, that's all for today. If you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another math easy solution.